Hi all. Today in this video we are going to solve a problem related to self-excited DC shunt generator. So we'll directly go to the problem. The question is a 10 volt 10 pole DC shunt generator with 800 wave connected conductors are running at 600 rpm supplies a load of 15 ohm resistance at a terminal voltage of 240 volt. The armature resistance is 0.28 ohm and the field resistance is 240 ohm. Determine the armature current, the induced EMF and flux per pole. Right? So they are given number of poles, number of conductors Z, number of poles P, number of conductors Z, speed N, and load current, load resistance RL 15 ohm and terminal voltage VT 240 volt. Also they have given RA, armature resistance as 0.28 ohm and the field resistance RSH as 240 ohm. We need to find or we need to determine the IA, current IA, that is armature current, and induced EMF EG or E and flux per pole, that is phi in Webers. So first let's write the given values. So given P is equal to 10, number of poles equal to 10, and wave connected. If it is wave connected, then number of parallel path A is equal to 2 always. This need to be carefully noted here, right? So next Z, number of conductors, number of armature conductors is 800, then now speed 600 rpm and resistance, IRL resistance, load resistance is equal to RL is equal to 15 ohm, right? And terminal voltage VT is equal to 240 volt and armature resistance RA is equal to 0.28 ohm. So these are all the given parameters, and one more thing, RSH, shunt field resistance, is equal to 240 ohm, right? From this, to find, we need to find IA, then EG or E is equal to, then flux phi is equal to, right, per pole. So we need to find three parameters. One is armature current, then generator voltage or induced EMF, and flux per pole, right? So let me draw the diagram first. We'll start in next slide. So the diagram for a shunt self-excited shunt generator is, this is generator, and shunt means the field winding will be connected in parallel with the armature winding. This is A, and this is F. This RA, and the current from armature connector is IA. The current flowing here will be also IA. The current flowing here will be ISH, because the field winding is connected in shunt with armature winding, so it is represented as ISH, shunt current, right? Normally you will represent it as IF, but due to connection of shunt, field winding is connected in shunt mode, so the current flowing through this is indicated as ISH, and this is connected to load resistance RL. RL is given, RL equal to 15 ohm, right? And the current here will be IL. Current flowing through the load will be IL, and this is VT, right? And this is the load, right? Normally we have load at the end of the connection, so this is the load, so the voltage across the load will be VT, which VT is terminal voltage, right? So and the resistance for this field winding is RS, shunt resistance, right? So now from this we can find IL, load current. IL is equal to VT divided by RL. We know the value of VT and RL, which is VT is equal to 240 volt divided by, let me check once, the value of VT is equal to 240 volt, right? Okay, and the value of RL is 15 ohm, so which can be written as IL equal to 16 amps, right? Next, IS sketch can be written as IS sketch shunt current. IS sketch is equal to VT divided by R sketch. Terminal voltage divided by RS sketch. IL is similar. IS sketch is similar to IL, right? We find our IL with the help of VT and RL, and we are finding IS sketch with the help of VT and R sketch, right? These two values are known to us. So VT is equal to 240 volt divided by R sketch is 240 here, right? So 240 by 240, which is equal to 1 amps. So the shunt current IS sketch is 1 amps. Now IA is equal to IL plus IS sketch from the diagram, from this self-excited shunt generator shown here. So IA is the current from the armature conductor. At this point it is divided into two current, one is IS sketch, the other one is IL. So IA is the addition of IS sketch current and IL current, load current and shunt field current, right? So IA is equal to IL plus IS sketch, so which is equal to, we know the value of IL and IS sketch from this relation. So 16 amps plus 1 amps, which is equal to 17 amps. So IA is equal to 17 amps. IA is equal to 17 amps. And EG can be calculated. So the first parameter, we have found the first parameter IA, armature current, which is equal to 17 amps. Now we are going to find the value of EG, right? So EG is equal to VT plus IA RA, where VT plus IA RA can be calculated by VT is equal to 240 plus RA is 17 amps into IA 17 amps plus RA 0.28 ohm, so which is equal to 244.76 volt, right? So from this EG is equal to 244.76 volt, right? We have found the second parameter, and the third parameter is flux. We need to find the value of flux. So we know the relation EG is equal to 5P NZ divided by 60A. So we know the value of P, N, Z and A, and EG. We need to find the value of phi. The unknown parameter is phi, flux. So phi is equal to EG into 60 into A divided by P into N into Z. So which is equal to 244.76 into 60 into, so this is wave winding, so number of parallel path A is equal to 2 divided by number of poles here is 10 into speed is 600 rpm into Z, number of conductors is 800. So the flux phi will be, so the flux phi is equal to 6.119 milliweber per pole. So this is the answer for the third parameter, right? So we have found the value of armature current, generator voltage and phi flux. Thank you.